In this presentation, we're going to walk through the process of setting up a basic player controller. So I have this mock-up here, and this is just a 1080p mock-up of what the basic interface should look like. It's not 100% complete, just kind of still sandboxing or riffing on some ideas here, but I did want to get a sense of what the enemy and obstacle and player are going to look like. And I do want to point out that the some of the player assets or some of the spaceships that I'm going to use are about twice the size of the target. So I designed them a little bit bigger. And I'm just planning on scaling these down about 50%. And early on in the design process, I don't have to optimize these really. So I'm just going to, rather than scaling these graphics down, I'm going to export them as is. And in Unity, I'll scale them down a little bit. Because these are 2D graphics, it's not going to be super intensive as far as the system resources are that it's going to require. I'm not too worried about any inefficiencies, but we will make a pass a little bit later on and talk about kind of best practices when it comes to this. But for now, we're just kind of in this riff phase where we want to focus on the design and the core mechanics. And so I'm going to jump over to Unity, where I've already exported some of these assets. And so I have a sprites folder, and I provided a copy of this sprites folder to you. And just want to point out that I have some individual assets in here along with a sprite sheet. Now, the first thing I'm going to do is I'm going to start with either the red or the blue spaceship. I've determined that the blue spaceship is going to be the player, but of course this is completely up to you. So I've called this one the Blue Hawk 01. I'm just going to drop that inside my scene. Now, I don't have a real clear sense of how this looks on screen. I know that it's twice as big, at least as twice as big as I want to use it, but there's no other references inside this scene. And there's a couple of things that I can do. The first thing I'm going to do is go to the game view. And there's a little drop-down menu here. Mine's currently showing 16:9. Yours might say something like free aspect ratio. Just giving us an idea of what we're looking at here on screen. And what I'm going to do, you can see that there's some different aspect ratios that are here. I'm going to create a custom item. I'm going to create a new item. It's going to be fixed resolution. And I'm just going to call this 1080p. So I'm going to set this up as a resolution that would show up for like an Xbox One. So the width of this is going to be 1920 by 1080. And you can look up the resolution standards for different devices. Again, this is kind of standard TV resolution at this point. I'll say OK, and that gives us kind of a preview of what the composition of our game is. We're looking at this at 1%. I have a pretty high res monitor that I'm looking at things, so the screen looks a little small, but it is in fact an HD screen. Now, this player is huge relative to the rest of my environment. And if I jump back into my design document, I really wanted this kind of closer to, this size. So if I were to stack these and just make a couple of duplicates, and I won't go all the way through with this, but you can see that I can fit like 5 or 6, just a really rough kind of approximation. I can fit, 6 or so, or even more, kind of stacked up. So just a really quick and dirty way to kind of, figure out how large I want this. I'm going to select my little player icon here, and I'm going to go to scale, and I'm just going to scale this in all directions down to 0.5. Maybe I'll take it down to 0.4. And again, I'm just kind of feeling my way through this, not setting anything in stone. I'll probably even go a little bit smaller than that. I am in the game view, so I can't select anything here, so I'll just jump back to the scene view. And I'll probably even take this down to like a quarter. And I'll revisit this a little bit here in a little bit. So let me see if I can get rid of my camera gizmo here. Well, rather than digging through all of these gizmos, I'm just going to hit the gizmo button and kind of turn that off so I can see this without the little camera icon showing up. So here's my player. I'm going to select this player, and in fact, I'll even call this player. But a best practice here for something like this is I'm going to start building up my core mechanics. I'm going to add a little playmaker state machine to this, and really the best thing to do is to create an empty game object and call this player, and then use the contents. Let's see if this is showing up. Let's zero this out. And then drop the graphic inside the player. So we have this empty shell of a player that's going to contain the mechanics, and then we have the visual of, we have the artwork of the player. And the advantage of doing it this way is that if we decide to change our ship or modify our ship or our player, or depending on what your scenario is, we could have multiple graphics under the player and just kind of have them swap out as needed. So I'm going to go back to my player here, and I'm going to get started by creating just a really simple scenario. I'm going to control this based on physics. Whenever we're making games and we're have some player controls to set up, we can either do it kind of as mathematical transformations, and we can do that by influencing the transform of an object. But I want to influence the physics. And I want to influence specifically the physics 2D here. So what I need to do is, with my player selected, I'm going to go to components, and I'm going to stay in physics 2D land. And I'm going to assign a rigid body 2D to my game object. Now, if I look through my game view, this is testable. I've added a rigid body, and in a 2D environment, when I hit the play button, we'll see that it causes my character to fall down. This is the y-axis. Okay, so gravity's still using y as the down, the up-down vector, but I don't want my graphic to be falling to the ground. Now, maybe I'll do some kind of top-down, side-scrolling shooter, but I actually want to be able to point in different directions and fly around. And we can come up with different ways that this should interact, and we can riff on this in our design document. But all I'm going to do is, with my player selected, I'm going to go find the rigid body 2D. And I'm going to go in here and try to find the gravity scale. There it is. And I'm going to zero that out. So I'm basically using zero gravity. And so now when I hit the play button, I shouldn't be falling anywhere. But if something bumps into me, of course, it should send me flying. Okay. So I'm in this really, open, empty scene, and I'm going to drop a couple of objects in here just for reference. And I'm going to do just a couple of 3D cubes. This will give me, a couple of things to demonstrate with. The first thing is that you'll notice this cube is not illuminated. If I go to the game view, this cube is showing up as dark, and that's okay. I'm just using this as a placeholder. But there's no lights inside this scene. That's another default for a 2D environment. So these sprites don't require any illumination by default. But I have this cube. Now, the cube has a 3D collider on this object. And if I were to happen to, say, components, physics, rigid body, so I have a standard 3D rigid body and a standard 3D collider, you'll notice that these objects won't interact with each other. If I hit the play button, this cube should fall and fall straight through the player, but it does not bump in or collide or interact. That's because there's two different physics engines, or two different layers to the physics engine, and they don't talk to each other. The physics, the 3D physics engine, and the physics 2D are two completely separate systems. So in order to get this 3D cube to function in a way that would kind of interfere with this object, we need a couple of different things. The first thing that we need to do is I need to get rid of the rigid body. So I'm just going to remove that component, and I'm going to also remove the box collider, because this is a 3D component, a 3D physics component. And I need to add a 2D rigid body, and then I also need to add a 2D box collider. So because this is the 2D physics, we need a corresponding box collider, otherwise we're not going to have anything to bump into. And I'll just add a simple box collider, and it'll utilize the dimensions of that shape as the box collider. Now, I do not have a box collider on my player, or a 2D collider of any sort, and I'm just going to select my player and add a very simple box collider 2D. Now, this box collider here, I'll just highlight this edit so you can kind of see this a little bit more clearly. And in fact, I'll just, with that edit 2D button, I can kind of tweak this around a little bit. So there's the bounding box for my collider. Now, there's a couple different things here that's interesting about 2D physics, and we'll take a closer look at this over the course of all these presentations. But when I hit the play button right now, you can see that these two objects are interacting with each other. The cube is able to interact because it has a rigid body 2D, and it also has a 2D collider. Now, we could eliminate the 2D rigid body, and it would stay in place, but because the collider's still there, we can still run into it and do some other things. My player has a 2D collider. It's ignoring gravity, so it doesn't move until it gets bumped by this cube. So now we have some, basic elements that we know are interacting with each other. Now, I don't want this cube to fall through space just yet. In fact, I want to be able to send it in all different directions. So I'm going to take this rigid body for the cube, and I'm going to find its gravity scale, and I'm either going to turn it completely off by typing in 0 or setting it so low that it would fall very, very slowly. But I'm going to set this to 0 right now. And I'm going to duplicate this just a couple times, and this is really just to get some kind of visual reference to be able to fly around inside my scene and know that we're moving without, just moving in this dull, flat background. Okay, so I got a few things that, we can kind of dodge and play with here. So I'm going to go back to my player, and remember that I have an empty game object. I have a rigid body 2D assigned to that empty game object, and I have a box collider here. And again, the advantage of that is I can take this player object and I can deactivate this, but I still have the player and the collider and all the stuff that goes into the control system. I just can't see it because I've hidden that artwork. And again, the advantage here is that we can swap out different artwork. We can destroy the player without destroying the player controller. There's a number of things that we can do. But let's set up just a really simple controller for this object. I'm going to select the player to make sure that I'm setting up the controller on the root of the game object. And because I'm using physics 2D, I want to kind of utilize my the physics 2D elements in Playmaker. So I'm going to add a state machine to my player, and this state machine, I'm going to rename it. I'm going to call this simply player movement, or I'll call it player movement. I'll go back to my state, and I'm going to call this idle. So if we're in this state, we're just idling and listening for some input from the player. And for now, I'm going to do just a really simple test to make sure that I get things to work the way that I want them to work. So I'm going to create a simple state machine that goes back and forth between idle and thrust. And so I'm just going to create a second state here. That wasn't even close to thrust. I'm going to try that again. Call that thrust. And I'm going to set up a simple toggle that listens for the spacebar. We'll change this later, but I'm going to go to the input category, and I'm going to do a get key down, and I'm listening for the spacebar. And if we get the spacebar, I want to send an event, and I'm just going to create a new event, and I'm going to call this next. It's going to be just a really kind of generic, simple event that loops back and forth between the two. I can resolve this error by clicking on the error, or just right-clicking and choosing to add that new next transition, and I'll wire that over. So the logic here is that if we get the spacebar, we're going to follow the next transition. So we'll go over here to the thrust state. When we're in the thrust state, I want to listen to my spacebar being released. So rather than a get key down, I'm going to do a get key up, but I'm going to listen to the same key. I'm going to listen for that spacebar. And I could borrow the same send event, the next event that I used in the first state, because this is just a really simple two-state machine. I'm basically just building a loop back and forth. So the names of these transitions aren't as important. But if you want to use two different transition names to keep it clean, go for it. So this is testable. I'm going to hit the play button. It's not going to do anything, but it should allow me to press the spacebar and watch this toggle back and forth. So if I press and hold the spacebar, we're stuck in the thrust state. And when I release, it goes back to idle. So at that point, I should be able to add a force in the thrust state and start to get this thing to move. So from the thrust state, I'm going to go to my physics 2D, and I could add force 2D, but to cut right to the chase, we're going to run into an issue, and we're either going to have to calculate. We're going to have to calculate the direction that we want to add force based on the direction that we're pointing, and either do a little vector math or try to figure out what direction we're pointing, or we could use this action that kind of has some features built in that says add relative force 2D. And what this means, if we want to add relative force, we're going to add according to the y-axis or the up direction here. And I'm just going to find the y value. I'm going to toggle this, and I'm going to use a value. I'm going to start off with 10. I have no sense of how much force I should use, and I'm going to do this every frame. So we're applying a force of 10 every frame along the y-axis while we're in the thrust state. So I'm just going to test this. I'm going to hit the play button and see if we can get some thrust going. And so when I press the spacebar, you can see it takes off and it does not come to a stop, and that I can see here that's still flying away on the y-axis. So in order to get this to stop a little bit more quicker, I'm just going to jump into the 2D rigid body, and I want to look at the linear drag. So the linear drag is going to cause this thing to slow down when there's no force. The higher the drag, the quicker it's going to come to rest. And so just typing in the value of 1, and I can see that now that's causing it to stop. So it doesn't come to an immediate stop, but you can see it's kind of, quickly coming to a stop, and that's fine for testing. Okay. Now, in this thrust state, we told it to add relative force to the y-axis. And the reason we want to use relative force is that we want to be able to take our player, and in the event, I'll just go to the rotation, and I'm going to rotate this along Z. As we change the direction of our player, we want the thrust to be applied not to the global axis, the y-axis, which would be up. We're adding force to the relative axis of our player. So in this case, it's in the direction of the y. So I'm just going to rotate this and make sure that this works, that when I add the thrust, it's pushing in the direction that I want this to go. Now, had I used the add force, I'll just kind of swap this here. I'm going to turn off my add force 2D and just temporarily use this add force. Excuse me, I'm going to turn off the add relative force and flip on the add force 2D, and I'll just use the same setup here. I'll say 10 along the y-axis every frame, so it's the exact same setup, just a different action, and we'll see what happens when we try to send this player along the y-axis. You can see that it's heading in the direction of the global y-axis, not the direction that the player is pointing. So that's the big difference between relative force and add 2D force. So we can actually just collapse that, get rid of this. I'll remove that action. So I'm flying in the direction that I want. The next thing I'm going to do really quickly is just set up a little simple torque, or we can think of this as kind of a rotate command. So we have our thrust set up, and we want this to run independently of everything else that we're doing. And so I'm going to click on this little drop-down menu here and add a second state machine. This state machine is going to be our FSM. This is going to be our player torque. Or we can call this rotate. Even though we're going to use torque, the effect of it is that it's going to rotate the player. So I'm just going to call it player rotate, even though technically we're going to be using a torque. And in this case, we actually only need to use one state. So what we're going to do here is we're going to get some user input, and we're either going to get the axis vector, and I'll just demonstrate with axis vector here in just a moment. Getting an axis vector listens to both the horizontal and vertical axes. That's the input from the user. And by default, the AWSD keys are mapped to horizontal and vertical. Same thing with the arrow keys. And the D-pad and the joystick, the left joystick on the standard game controller, all talk to the horizontal and vertical axes. So in order to get this to work, we need to store the user input in this store vector. And so I'm just going to create a new local variable, and I'm going to call this player input. So always starting off with lower cases, never using any spaces, no crazy characters in the variable names, and I'm going to create this new variable. Now I'm going to hit the play button. I'm going to click inside my scene in the game window to make sure that my player has focus. And as I mash my AWSD keys around, you can see that I'm getting different values in my store vector. So if I press up, I'm getting a +1 in that third item in the vector 3. If I press down, or the down arrow, up arrow, or the W and S, you can see I get a negative. So I'm operating on a scale of +1 to -1. Whenever we see a vector 3 or 3 numbers together like this, it's X, Y, and Z. So this get access vector right now is listening to the XZ mapping. We can change that, and in fact, we're going to want to here, but we're actually only we're gonna create a little custom setup here anyway, so it's not necessary. But the thing that I wanted to point out here is that we're actually listening to two different axes. The horizontal axes, the left and right, is this X, left and right, and then the up and down in this case is the Z. But what I really want to do is I just want to listen to the horizontal axes. So when I press my left or right key, I want to influence the horizontal axes and capture that input. So I'm going to toggle the play button. I'm going to deactivate my get access vector, but to save myself a little bit of time, I'm going to copy this horizontal because I'm going to use that label here in a moment. And I'm going to get an axis. So the axis name that I want to listen for, I'm just going to paste in this horizontal. And I'm copying and pasting because this is all case sensitive, and if we miss a typo here, it's not going to map our horizontal input. I'm going to change the multiplier to 10. And I'm going to store this in a new variable, and I'm going to call this player ROT, player rot or player rotation. Even though it's technically going to be applied as a torque, I'm going to say rotation. It's going to happen every frame, and I'll hit the play button. It's not doing anything yet, but I do want to show you that when I hold down the left key or the A key, I'm getting a -10, and if I hold down D, I'm getting a +10. So I've change that scale of the horizontal input based on this multiplier. Okay, I'll toggle the play button. I'm going to take this value that we're capturing in player rotation, and I'm going to do an add. So I'm in the physics 2D, and I want to add torque. So somewhere in here, add torque 2D. There it is. I'll double click. And when we're adding a 2D torque, we really only have one value because an object, according to 2D, is only going to want to rotate according to the Z axis. So what I'm going to do is I'm just going to utilize that player rotation value. So I went from a hard value here. I clicked on the equal sign. That allows me to select this variable that we're capturing, and I want to do this every frame. So the result here is that we're going to get our horizontal mapping from the user, our left and right keys. We're multiplying that by 10, and we're going to add this to the torque of the player. Now it's going to be probably a little crazy looking. It's going to be a little slippery and kind of go all over the place. It might not even rotate around the place that we want to rotate around. And you can see that it continues to spin. So there's a couple things here I can kind of control it and cause it to stop, but it's super slippery and there's, you know, all sorts of stuff that needs to be fixed. So the first thing I can see is it's rotating around a point somewhere in here. So I'm going to need to fix that right away. And I can do that really simply by just aligning the artwork to the parent object of the player. So if I go in here into my player artwork, I can just kind of manually move that. I am going to straighten this back out. Alternatively, what I could do is I can probably just get away with zeroing out the y-axis for the artwork to make sure it's lined up with the player. So I'll hit the play. I'll play this again really quickly and make sure that it's rotating. And that's for now. That's fine. That's where I want it to rotate. I'll tweak that a little bit later and make sure it's rotating exactly around the point that I want. But you can see that this is not stopping. It's continuing to rotate. That's a very slippery setup. So I'm going to toggle the play button, and I can start to fix that by going into the player, into the rigid body, and start messing with the angular drag. So the linear drag slowed our object to a stop when we're moving in a linear fashion. The angular drag is anything that's got a torque or a rotational force to it that will cause it to, the higher the drag, the quicker it'll come to a rest. So I'm just going to experiment with the value of 1, and I'm going to hold down the right key and the left key. And so for those of you out there in YouTube land, this you might notice that when I hold down the left key, it rotates clockwise, and I hold down the right key and it goes counterclockwise. So this is the exact opposite of how I want this to work. Okay, I'm gonna bump up the angular drag. I'm gonna double that real quickly while I'm here. So I'm gonna go back into my player rotate mechanic, and I want the opposite controls to work. Because we're using this horizontal multiplier here, I just want to invert the values of the torque, and I can do that really simply by just adding a negative value in front of my multiplier. So this way this will invert that. So when we take a positive number and multiply it by a negative, we get a negative number. When we get a negative and multiply it against a negative, we get a positive, and we would get the opposite if we're you know, inverting that to a positive number. So just a really quick fix will cause that to work. So now I'm rotating to the left, rotating to the right, and I can also hold down my space bar. It's really out of control, and I don't like the space bar as a thrust, but I'll fix that a little bit later. So I definitely want to kind of fine-tune my rotational drag or my angular drag. I want to kind of tweak the rotation point of this, but otherwise I think it's starting to work okay. So getting some basic controls. In the next presentation, I'm going to tweak this to map this to a vertical axis, so we're not holding down the space to get this to move forward, but we're using the WS or the joystick or the D-pad or the arrow keys. But we'll do that in the next presentation.